All right, welcome back. This is our video stream, live stream number 9. And in this one, we're going to begin our enemy collision detection. Starting with, initially what I want to do is to be able to, using the similar scripting that we did for the player controller to get it to deflect or bounce off the walls. We want to come up with something similar for the enemies. Now, the enemies are going to be different. We're not really going to have a script that's tied to each enemy. In the original Space Invaders game, they kind of move as a group, like an army of enemies. So what we're going to need to do is have a script that's controlling all of them at one time, and so it moves them as a single unit, sort of. And because of that, we're not going to be putting that script on a single enemy object. What we're probably going to do instead is tie it to the plane, which could be considered our base world, the ground. We'll apply it to that, since we already have. If we look at the plane object here, it's already spawning in the cubes. It has a spawn cube script and a spawn enemy script. So it's already spawning the enemy, so it'd be a perfect place where we can put our code for that. Now, we probably could modify the spawn enemy script and add the code in there. Let's actually take a look at that right now. Our spawn enemy. See, all we have is this start function. So that's called the first time. It's the initialization of this script. So the first time the plane object is when it's actually created in Unity for our game. This start function is ran, which generates and instantiates all the enemies. So we've got that there, and we could do down here, we could add further down, we could add the update function or use whatever functions we need to run during each frame over there. But I think to kind of help organize all this and keep it separate, I'd like to create a separate script called move enemies, and we'll just put all the code in there to kind of keep it separate from this. But again, we could have easily combined it, but it's just easier to have it separate. If we ever need to go back and troubleshoot what's going on, it's easier to look at a script that's primarily for moving the enemies, as opposed to a script that's for creating them and moving them. So let's go to get started in this. I'm looking at these icons. I'm still not okay. It's Unity, so we need to go back on the plane. Okay, whoops, I didn't mean to change that. We're going to add another component here. We're going to add another script. So let's scroll down, new script. We're going to call this move enemy, even though we could say move enemies. All right, we've got it in C#. So it's creating that script. There we go. And just initially when it creates, I don't know if you saw, it said nothing selected here, and it took it a while for Unity to create this script, attach it to the Unity project, the game scene, and then it compiles it in the background, initial compilation to make sure it's all kosher. So, and then it shows it here. So once I saw that move enemies script, I knew we were ready to go with it. So what we want to do is now look at our assets folder. Let's click here, because by default, anytime you add a new script, it puts it in the root of the assets folder. Now, we decided earlier in the last video before last that we're going to organize our project in these different folders. So if we come up with a new type of asset, we'll create a new folder for it and add it in there. But we have a scripts folder, so I'm going to click this, click and hold on the move enemies, and we're going to just drop it into our scripts folder. Or I could just go up here. It doesn't really matter. In either case, it's moving to the scripts folder. Now, if we click on the scripts folder, you'll see we have our move enemies. So there it is. It's loading a preview of that. Let's go ahead and open that so we have that in. There we go. So we have our two other scripts there, player, controller, spawn enemy. Now we have remove enemies, and that's our basic skeleton of a script here. So anyways, what we're going to do is let's think about what we want to do with these enemies, at least in this video series. We may not be able to do everything with collision detection, but what I want to accomplish this time around is getting the enemy cubes with the green little goblin faces to move back and forth on the game scene. So essentially, like bouncing or moving off the walls. As they hit the wall, they'll change direction as a unit and come back. So if we kind of reference the player script for some insight, we know that we controlled the direction that we were moving by what the user would press, the A key or the left arrow key, to give a negative X direction, and the D key or the right arrow key, which gave a positive X value, which could be applied to the transform to move the player controller cube from left to right. So we know that we're going to have some kind of direction, but we're going to have to manually control that. We're not going to have input from the user. You know, we're also going to have a speed, probably a min and a max, similar to this. So let's see. Yeah, so I'm trying to think, is there anything else we might need? But anyways, let's do this. Let's go to move enemies. Let's go ahead and define what we know we're going to need. We want to create some public variables again so that we can manipulate those in the Unity editor. So we don't have to keep jumping to the script here and then jumping back, and it's just easier. So we're going to have a public float speed, just like we did in the player controller. We'll also have a public float min x and a public float max x. And I think I got an extra x in there. So okay, those are publics. And then we know we're going to have to control the direction. So let's do private float direction. Now we don't want that. It's not going to be manually controlled one time through the Unity interface. That's going to be controlled in this script, because once this script starts running, it'll continually run every frame in the update. You know, this update function down here will be called every frame to continue movement of the enemies. They're never really going to stop. They're going to keep moving. So the direction is going to be controlled dynamically in this script, and it'll be set accordingly. Now the start is great for initialization, so we can go ahead and assign a value to direction here, which will start off the direction. And we can make a decision as the programmer, and we're creating this. We can decide, okay, do we want the enemies to start going right? Do we want them to start going left? It don't really matter, but what we're going to use, since we're going to use the value of direction to be similar to the way the inputs work. Like if it's a negative value, the input is in a left direction. If it's a positive value, it's in the right. If it's 0, it's neutral, sort of like the enemy would be standing still. So so let's say direction. We're going to go in the left direction first. Now I'm going to put a note here next to direction here, a little comment off to the right here. And we'll just say left is going to be represented by -1. Right, oops, I meant to do a comma. Right will be represented by a +1 or +1. And we'll just say that if direction is set to 0, that means the enemy should stop, which in our case, we're really not going to have that, but we're trying to be consistent with the way the player controller works, because when you don't press a key left or right, you know, it's actually the value is 0. If we were to monitor what x would be at that point, it's a 0. So it starts going in the negative direction as you hold it left, and positive direction right. So we'll just use those values, -1 as left, 1 as right, 0 stop. All right, so that's going to be the initialization part. Now in the update, we're going to have to basically be moving all these enemies the same distance. So they're going to move in unison. So we need to use some kind of loop so that we can loop through all these enemy game objects. But you know, how are we gonna do that? And I think we're gonna use something similar to what we did with the walls, the left and right walls. We created a tag called left wall and a tag called right wall. I think we're gonna create a tag for the enemies. And since we're gonna be doing the same thing to all of them, it's not really gonna be anything unique. We can just create one tag called enemy and identify all of them that way. So so we don't forget, I want to go ahead and do this right away. All right, so let's go, I guess it really don't matter what object we click on when we're creating this because it always resets. But we're going to add a tag. Do we have an enemy here by default? No, I don't see. I see respawn, finish, editor only, main camera, player, game controller, left wall, right wall, which are the two we added. So we're going to add another tag called enemy. We'll save that. Okay, so let's go to our prefabs because we don't see an enemy game object in the gameplay scene. Those are created dynamically when we first hit play. So where we'll have to set that tag is on the prefab. And remember, the prefab, anything done to the prefab, it's automatically going to be in all the instances of the prefab that are generated dynamically. So when we assign this enemy, we can pick the enemy tag down here. All of our instances of the enemies will have that tag. So it'll be easy to identify them. And we can use the function we mentioned in the last video to be able to find game objects by tag. We'll use that function to gather up all the enemies collectively and store them in a list, or what's essentially an array, which I'm not going to get into what an array is, but it's basically a list. Just think of it as a list of all the objects of the same type, and then we'll be able to iterate or go through that list and do something to every single one of those enemies, which would be readjusting its X position to make it move, or its Y if we're going from slowly moving down the screen. But right now we're focused on the X position, and we're going to get the collisions working on the wall, left and right. And then probably the next video we'll look at readjusting the Y, and we may do it at the end of this video. It just depends on how long it takes to get to that. I don't want to make it a really long video. So anyways, let's move on. So we have our enemy prefab tagged as an enemy, so all our dynamic instances will also have that tag. Let's go back to our scripting, and like I said, we need to gather up a list of all the enemies. Like at the start of this game, when it runs, we're going to need to have a collection or a list of all those enemy objects, game objects that have been spawned. So we probably don't need to do that every single time, every frame. We can get the collection at the start, and then we'll let's see. Or will we need to get it every time? Probably not. I think we can have a list. Once we save that list, like later on, I'm trying to think ahead. Later on, when the enemy gets destroyed, we should be able to remove that enemy from the list, so the list will slowly get smaller as needed. If we were to gather that list in every frame, like in this update function, if we'd write the code we need to gather that list of enemies, it would be doing that like every frame, and it's going to eat up a lot of resources and really slow down the frame rate. So we don't need to do that. We just need to do it initially. We're going to do it one time. So let's do that right here. Let's see what we've got here. I know, we might have to reference the documentation again. Actually, we're at gameObject. That's kind of where we're at before. Let's click that again. There was the find gameObjectByTag function that I saw. Okay, static methods. Here it is. Find game objects, multiple. Find game objects with tag. Returns a list of active game objects tagged, tag, whatever the tag is. Returns empty array if no game object was found. Well, we know we're going to have enemies in there. So, anyways, let's click on that. Let's see how it's used in this example. And we don't really need to read the description. I'm more at the point now where I want to see how it's used. Yeah, so it looks like they do it like what I was thinking in the start would be the best way to use that. They're doing it for a respawn, and then they're generating, like, I guess, a spawn object. So they're creating multiple spawns or multiple spawns that are out there that they've already set up, and then they're finding those spawns and then spawning some kind of prefab, game object called a respawn prefab into that respawn position. It's going through the positions and spawning stuff. That's pretty cool. I'll need that down the road if I ever do a game that requires spawns. So anyway, so it looks like they're assigning, when they use this game object that find game objects with tag respawn, they're assigning it into this respawns variable. And the respawns variable is declared up here. So it looks like we're going to have a respawns game object. These two little square brackets after it indicates that it's an array. It's going to be one or more items that'll be stored in that array. So I'm going to copy that. And it looks like, now they did it as a public, which I don't understand why, because it looks like, in what we're doing right now, we're not really needing to expose the enemies as a public thing to Unity. We're going to be doing this all in script, so we'll make ours private, because, and if we later see that we need to make it public, or that another script maybe needs to access the game object list or array, I guess that's why we make it public, so it's accessible from outside that script, not only in Unity, but maybe from another script. So, but we don't need to do that right now. So let's under here, I'm going to paste that public, whatever. We're going to change that to private though. Private game. Okay, we're not going to call it respawns. These are going to be enemies. So that's our variable name is called enemies. And so in the start, we're going to do something similar to what the documentation was doing. It looks like they're doing this check if respawns equals null. Null is a built-in thing that's been in C#, C++ programming languages for a while. Essentially what it means is null is nothing or uninitialized. And so what this if statement is checking is that if respawns is equal to null, which is an uninitialized value, then it wants to go ahead and populate it with whatever game objects it finds. So if the respawns array already has a list of game objects, then it doesn't want to overwrite it. You know what I mean, with new information. So that's kind of why they do that. So we're going to do the same thing. Except, again, our variable names will change. We're going to copy that. And we're probably not going to do the for each part. We'll use maybe a for each, I think, but not in the way that they're doing it. So let's go back to our script. So we're going to say if enemies, enemies equal to null, then game object define game objects with tag, and we just added a tag called enemy to our enemy prefab. So okay, that'll get us our list. And now this is called, update is called once per frame. So in here is where we could then like update the position of our enemies using the direction and the speed value that's set. And I forgot what min x and max x were going to be. Okay, that was for our left and right, closest to the wall, those values. So we'll have to set those as well. All right, so let's do this in the update. Now we're going to check here if it's always good to check your lists and arrays, even though we expect to get a list of enemies in here. I don't know how much time delay there is between when start is first ran and the first frame runs this update function. They could be called back to back almost instantaneously, one after another the first time, and then update is run successively after that, or continuously every frame. So we want to check to make sure before we try to do anything with the array of enemies that it's not equal to, this is how you say not, instead of equal to, not equal to null. If it's null, that means it's empty. If it's not equal to null, then we want to do something with it. So and what we're going to do with that is, like we said with the way we move the player controller, we're going to be creating that vector3 variable, extracting the current position, and then adjusting the x value, and then reassigning it back to the transform position. We need to do that for the enemy though. So now, in order to go through this array, every single object, game object in this array, enemy array, is we got to use the best way is to use a for each, because you don't have a for each statement. That does not require that you know how many items are in that array, because the for each is designed in such a way that it goes through each and every element or item in that list, that game enemy list or array. So we don't have to worry, hey, we don't have to do a check, is there 20, 30, 40, 50, or 100? It's not going to matter. The for each works for all those sizes, so it don't matter. So the way it works is for each, and then we put a our type that we're looking for. Now we're storing in there game objects is what we're actually storing in that array, even though they're tagged with enemy, but they're all game objects. So for each, and then and basically in this, what we do is for each, and you got the open and close parentheses, but inside this is where we set up some things. One is the first thing being the type. The second thing we're going to type here is the the variable that we want to use inside of our for each loop to be able to access like that individual enemy. So whatever we're going to do to it. So we create a variable name, and we'll just call it enemy since it's singular, since it's just one enemy. And then you say use the keyword in, and you give it the name of your list or your array of game objects called enemies. So for each, and if you want to read that, for each, so for each game object enemy in enemies, do something. And so this will allow us to go through and now on each enemy we're going to do something. So we're going to look back at our player controller code just so I can show you as a reference. And we did this kind of thing here. We did the vector3, and we grabbed the current position of the transform of the player controller, and then set the value of x, and then transform that position, new position. We're going to do something similar to that. We're going to definitely have those 3 lines of code, maybe not exactly the same. But so the first thing we need to do is get on this first enemy. we need to get its position. So we're going to say vector. There's a vector 2. We're using vector 3, 3D space. Vector 3, and we're going to just call it temp because it's a temporary position value we're getting. We don't really care. After we use it here, we don't care. Vector 3 temp equals, and we're going to use our variable name we created for a single enemy that we're going to reference. Enemy dot. Enemy itself is a game object, and inside the game object there's a transform dot position, and from the transform we can access the vector 3 value called position, which will give us that. So whereas in the player controller we didn't actually have anything before the word transform, that's because it was a single game object for the player controller, and we were accessing the script that we were running was actually attached to itself, to the player controller, so it doesn't need to reference itself, just its transform. So we could type it out directly like we did if we go back there. See, we just did transform.position. But because we're now running the script from, well, we are running it from the plane. It's attached to the plane game object, not an actual enemy object. But that really doesn't matter. What's important here is that we're accessing an array called enemies, and the way the for each works is it'll take one item out of the enemies array and assign it to a variable called enemy. So that's how we're going to access the transform.position of whatever enemy we're currently looping through with the for each. So I hope I explained that. Okay, so vector 3 temp equals enemy.transform.position. Now we want to adjust the position, and actually this part is pretty straightforward. Temp.x, temp is our current enemy, equals, we're going to take temp.x, which is the current value of temp.x, temp.x, and we're going to add, basically using the speed and the direction. We're going to take the speed, which is a public variable we set up that's going to allow us to control the incremental speed or the number of pixels in 3D space, if you want to think of it that way, but it's really not pixels. It's really just a value. It's a floating point value, which can have, it's not whole numbers or decimal numbers. So it's a distance in 3D space in the x coordinate system, x direction, whatever. We're going to multiply that speed times our direction. Now, the reason we do that is the direction will indicate whether that speed value, which is always positive, we put it in as a positive value in Unity, on the Unity side. And so the direction can be negative or positive based on the direction of travel of the enemy. It'll be -1 when it's traveling to the left, +1 to the right. So if you multiply the speed value times a -1, you get a negative speed value. If you multiply it by a +1, you of course get a positive speed value. When it's added to the existing x value of the current enemy, negative or positive, it'll adjust it in the correct direction, negative or positive, that we're moving. So it's very simple the way that works. That's all we need to do for that, and then we just need to say enemy dot, and we're going to just reassign that value back to our current enemy object, game object. So enemy dot transform dot position equals temp, and we just say it like that. So that should allow us to move based on our direction. Now, initially, like we said, we set the direction up here to -1, which means we're initially moving left. So now we're going to have to write some kind of code in some way that's going to change the direction. So like when we hit the left wall, we want the direction to change, but when we hit the right wall, we want it to change back the other way, because if you have played Space Invaders and you know how it works, they're going to be moving left, starting left, and then when it hits the wall, it'll move to the right. When it hits the right wall, come back to the left as it's moving down the screen, as they are. So let's kind of think through this and what we're going to need to do. Because moving to the left, the actual X position is going to be the X position of, you know, basically the first enemy on the left side. That's really in that first column, the very first column on the left, in their little army of enemies. It's really the X position of that first enemy that's going to collide, whichever one is in the far left column, the first one that hits the wall. We need to, that at that point it should get triggered and switch directions, the entire group. So and on the other side, when they're moving from from left to right, once they hit the right wall, it's really the X position off of, we're going to have a different X position there because it'll be off the enemy that's on the far right. So we're going to have to probably have a way to, I'm trying to think through, like, while this game, something that'll work later on that we don't have to change. Like, initially we have all on the left side. Let's start with the left side. We have all the enemies in there in that left column, top to bottom. We have 5 rows, I think, 10 across each row. So we have five enemies. And as we're playing the game, if we shoot some of those out, we might have different enemies, or we might even shoot the entire left column out, and so it's just the second column then, that becomes the ones we're keeping track of as far as for collision on the left. So I guess what I'm getting at is our X values can change in either direction, really. It's going to be a dynamic value that's changing. So we need to have some way to track like the lowest X position from any one of those enemies and the highest X position. So on the other side when it's moving to the right. So, and then we can compare that with our, what we call our min and max here that we have set up here, which would be kind of the boundaries of the movement for the enemies back and forth. So it looks like we're going to need to add, thinking this through, 2 more variables. So let's go ahead and do that. Let's add, and these are going to be private variables, so we're only using them internally in the script. So private float. Let's call it, this is for the X that we're concerned with. X, call it low position, and private float X high position. The high meaning the positive, and low is the negative. So we're really just want to have a variable that's going to hold depending what direction you're going, and we'll hold the highest and lowest. And like, we don't want, if we don't do that, here's what I start to sometimes I overthink things, and I may be making it more complicated, but we can't just go by the first collision. Well, I guess we could, but let's see. I'm trying to think this through, but I think during each pass, during each frame, we need to store, for reference, the lowest, like I said, the X low and the X high. So we have that available and for use. So what we're going to do is, after this for each, well, no, actually it'll have to be inside where we're tracking it. So because we're going to track this, we got to check each game object. Maybe, like I said, we may not need this, but I'm going to do it for now. As we destroy these game objects, the enemy game objects, we're gonna we're not actually going to destroy them as to take them out of the game. We're going to use, there's a function called set inactive. What set inactive does, and I saw this in when I was watching the rollerball tutorial, they use that to, when you set it inactive, it becomes non-existent in the scene. So it takes it away from the scene, but as far as in memory, the object is still there. And so I don't know if this find game objects with tag enemy also collect the, that's probably something I can look up, also collect the enemies that are not active but also have that tag. So anyway, I don't think they do. I think it's just going to get the active ones, but for the sake of this, let's just do this. We're going to use this X low position, X high position to just evaluate each of these temp values as they're being generated here. We'll say if, let's for example, if temp.x is less than the current X low position, then we basically want to assign temp x to X low position. We're trying to get the lowest or the furthest leftmost X position negative value for that. Same for the high position. If temp.x is, if it happens to be greater than X high position, the reason I'm putting it here is because we can, it's not going to matter direction. Since we're tracking both the extreme left low position and extreme high right position of the X value, in this code, we won't have to worry about it's direction independent. It's not going to matter. We'll have those values either way, and so we can evaluate whichever one we need when it comes time for that the direction. We don't have to. Otherwise, they have to put another check in here. Like if the direction is -1, basically moving left, then we're really assigning X low position equals temp.x, and then I'll have to add another if statement in there. And it's, to me, it's just doesn't even. It's not going to save anything on time or frame rate by worrying about something so minute as that. Okay, so if temp.x is greater than X high position, then we want to say X high position is equal to temp.x. So that's going to temporarily, that'll store each frame. It's going to store the extreme negative X position and the extreme positive X position of the enemies that are currently active in our group. So so we'll have that. Each frame will know what those values are at each frame, because this is being done in the void update, in the update function, which is called once a frame. All right, so we've got all that, and what I want to do then outside of this for loop here, let's do a debug statement. And we're going to log that to the X low position / X high position colon. I want to be able to see what those values are as you know this is moving. So X low position. X high position. So we're going to log those, and we'll have those, and that'll help us. I guess that'll help us in determining again what the extremes are going to be left and right in code here. So I guess we can do some of our checks. Let's see. We've got a remember this min and max that we have up top here. That's going to allow us to control the extreme low X and extreme high X values that we want to set as the imaginary boundary of the enemy boundary left and right before they actually collide into the wall. We don't want them colliding into the wall. Actually, the enemies, let's take a look at them. So I think when we did this, yeah, see the enemies have a rigid body component. And if we look at our walls, they also have a rigid body. And what we've learned about components that have rigid body, they are affected by the physics engine, which means if we're not careful here, our enemies could collide into the wall if they hit the wall, which causes them potentially to stop. Like, just picture, they're not going to move in unison because they're going to start piling up on each other more or less, and you know, get out of whack. So we're trying to prevent that because of the fact that rigid bodies. Now, we've already done this. We've already put this together, and I may go back later on and we'll change this because in the beginning, I assumed. I don't know if I added the rigid body, or I can't recall if I added the rigid body or if the rigid body component was already in there by default, because it was primitive and it just includes it in there. But so anyways, we have to take that into account. We don't want it to collide into the wall and have all these cubes colliding into each other. We want to make sure the army of enemies is moving in unison, and the only way we're going to do that is if we're controlling their movement and not allowing them to actually hit the wall. We want to get them close to it. We're just simulating them moving back and forth anyways. We have control of that as the programmer of the game. So as the developer, we can do what we want. So that's what we'll do. So remember, the min and max, if we go back to, let's see, plane. Oh no, let's go back here. Let's see. Yeah, move enemy. Oh, we haven't saved it yet. That's why they weren't showing up. It's got the little star. Anytime you see a little star next to a file name, it means it hasn't been saved yet, the changes we've made. So that's why those weren't. Let's save that just so we have it saved. That's why Unity did not update and show, you know, the speed, the min, the max, anything we had public here. I like to keep all the publics together and the privates below that. So when I'm looking to add one, I'll just put them there, and I know those are the ones that will show up inside Unity. Okay, so not getting sidetracked when we're talking about the min and max are going to be values that we can set externally from Unity that will be plugged into this script as boundaries for the enemy. So the X low position, X high position are values that we're calculating as the enemies move every frame. We're calculating each frame what our lowest value of X is and our highest value. So we have those, and then we're going to use those values to check against min and max. That's kind of where I was getting at, and I guess I went to this long speech about that. And we also need to be checking the direction when we're checking our min and max, because we're not going to be checking max X if we're moving to the left. We're going to be checking the min. When we're moving to the right, we're going to be checking the max and not the min. So we're going to need to set up some if statements for that. And we do have this debug.log statement set up, which will log out the values. So let's see, underneath the for each, and I like to set to show these little data lines. That lets you know that this block of code is connected right here. That's all together. The if enemy is not equal to null. And so we're going to still be writing within this if enemy is not equal to null block here, because, you know, if there's no enemies to worry about, we're not going to be writing this code. So all this needs to be contained within here, but outside the for each, because we're going to let the for each go process every enemy. And once it does that, it'll move on to the debug.log statement we have, and then we can do our checks. And we'll have in these two lines here, the X low position and X high position will be set to the lowest possible and the highest possible value that has been calculated as it went through the game the enemy game object. So we're going to do our next if statement. Let's do the left direction first. So if direction is equal to, when you want to do an equality check, or whether two values are equal, you use a double equal sign in C#. If you do a single equal sign, it's called an assignment. That's when you assign a value to it, and it actually alters direction if I were to just put a single equal sign. So we don't want to do that. We're going to compare the two values. So double equal sign. So if direction equals -1, which we said was left, we're going to do one thing. And then, but there's also another check that we want to do, and that's what we're basically trying to check here is that when it reaches, when x, moving left, when x low position, which would be our negative x position, the lowest negative x position we could have for the group of enemies, when it gets less than what we've designated as our minimum x, then we want to do something. We want to change direction, basically, of the enemies and have the whole group start changing the opposite direction. So, but we want to do, this is what's called a compound conditional statement, because we're going to be doing a second checker. We're going to say, first of all, if direction is equal to 1, and we're going to use 2 ampersand signs, which is which is like and they both have to be true in order for this code to be executed. So if the direction is equal to -1, which means if the direction is equal to left, and our x low position, which is what has been calculated as the lowest negative x position of our enemy group, if it's less than our minimum x, then we're going to do some block of code over there. And so the first thing we're going to do is we want to change the direction manually of the enemies. So if they're marching left, we're going to make them march right. So we're going to say direction is equal to 1. Okay, change direction of enemies to right. Okay, and so the x, once we do that, then we don't really want the direction to change until, because they're going to keep marching right now until they hit the right wall. So we don't really want any other checks to be occurring that could alter the direction, like on the next object or the next game object is checked, enemy object. So we want to reset the x low position, basically clear it out. That's a better term. We're going to clear the x position by just setting it to 0. And so by setting it that way, it's 0 is obviously greater than our min x, so but it's less than our max x. It won't really go into either state. It's just going to set that position to 0, and this won't be executed a second time. So we're going to do something similar for the right direction. So we're going to say, in case the direction is equal to 1, which is the right, and x high position, if it's greater than what we've designated as max x, which are it's the value we plug in on the Unity side and the public variables we set up. It's our right side boundary for the enemies. Then we're going to change them to the negative direction, so they're moving left. So direction equals -1, x high position equals 0. So, all right, so we've got that. So that should be all we need to get this to work. So let's save that. Now, this is just the code that moves them left and right. So essentially, I want to test to see if they'll continue to bounce back and forth, left and right. We still don't have any code in here to actually march them down the screen, but we'll work on that next. I think we're going to have time to do that, or I kind of feel inclined to finish that up. And then we'll make the next series, next video about checking for collisions with, we got to start having our player controller fire missiles or cannons or however. I think we're going to use a small sphere, like a it should be like a cannonball. It'll shoot it up and try to aim for the enemy. So we're going to have some stuff going on with that, but right now we just want to march down the screen. So let's go back to our script, our Unity. We're on our plane. Let's wait, it's apparently updating the script. There it is. It added our 3 values here. And one thing I just found out, I was trying to see if you could do it. You can't, when you click here in the box, you have to type the value. But if you actually hover over the public variable name that we've set up in the script, you see you got like a little double arrow on my mouse. I can actually click here and then drag left and right, and it will set that value. You could just, almost like a slider. But we know that our speed, we're not going to have our speed up very high initially. I don't even know what speed we're going to try. Let's start with a speed of like 10, I guess. I don't know. That might be too. I don't know how this is going to affect the enemy movement. We'll just have to try it. Okay, so min-x and max-x. I'm trying to remember if we determined what those were. I didn't really write them down. I was trying to remember. We had like 6.25, but I think that was for the player controller when we were in that script. It was 6 over here, 6 and 6. So, alright, so we're going to have to play around with some numbers. I don't really know what they are. What we're going to do, since we have, again, we have, let's go back here. Move enemies. We have this debug statement here. It's going to show our X low position, high position. After they march back and forth. So we're going to just let it run and go. We don't even know what the X, I guess we have to have some kind of value in there, otherwise it won't work. So let's start with the values we had for the player controller, 6 and 6, negative 6, 6, and then we'll readjust it, if we need to. So on the plane, speed is at 10. We'll do this negative 6 for the minimum, max 6, and again, I think that might actually change. I don't know. We've got a block of enemies, not just a single. So let's see what it does. Okay, so it's not doing anything here. All it says is low position, high position, 0, 0. All right, so let's step back here. Let's stop this. They're not even moving. Oh, they should be moving. Let's check one thing. And I suspect it has to do with what I was saying earlier. I don't necessarily know, like, if this update is ran immediately after start, the first frame, and so it's possible that enemies is still null. It hasn't actually been populated with our enemies yet that quick, and so we might have to put some sort of a delay in there. Let's do a quick search, see if there's a way to delay it, and we'll see if that's the issue. How to delay a function via time. How to delay a function. Okay, this one is showing do an IEnumerate reset float count. You'll return new wait for seconds count is the amount of time in seconds that you want to wait. Here goes your method of resetting the game. Return null. That's one way. Is there any other options? Is there code for a wait or delay? Let's see what this is. How can I make a C# method wait a number of seconds? That might be something as well. Let's see. Come on, load. Why is it not loading? Something must have just stalled on this Edge browser. Just had to refresh the page, and then now it's spinning its wheels. So you get something called a late update. Unity 3D how to delay method with invoke. Let's see what this is. Okay. Okay, so now I added an invoke. So the first one goes off, and it looks like you did something with a 6.5, which obviously with this timer, it must be at 6.5 seconds. Boom. Cool. So how you can delay a method with invoke. Okay, so that kind of helps right there. That's probably what I want to use here to see. I want to delay a little bit and see if well, let's do this. This update, it says if enemies is not equal to null, then do all that. But if it's equal to null, okay, well, let's do this. Right in this update, debug. We'll put it at the end, actually. Let's see. Okay, length is a property of arrays that gives you the number of items in that. So we're going to log that out to the screen so we can see actually when this is ran how many it's picking up, because we have I think 50. We have 10 by 5. So if we look at spawn enemy, yeah, we have rows, we have 5 columns, 10. So 10 by 5 is 50. So we should have. Let's see what it shows. Because the position obviously is not moving, but maybe we have something wrong there. Yeah, it's showing enemies as 0, so that's what I suspect. It's not picking up or defining the enemies. So make sure we have our tag correct also, because if I didn't tag everything correctly, the enemy tag the enemy E-N-E-M-Y. Let's make sure our spelling's right. Okay, so that is right. So what we're going to need to do is take this out here. We're going to have to create a new function here. Void update, blah, blah, blah. Down here, void count active count, or find enemies. So we'll do that. So we'll put that in that function called find enemies, and then we can call find enemies up here. But we're going to use, like they showed that example, it was invoke. And in quotes, they had the name of the function, which we just made one called find enemies. The second parameter you pass in, it says float time. It's going to be a time or a delay. Let's see if we can just do like a, we don't want to wait that long, but a 1 second delay, 1.0 f. So a 1 second delay. And then it'll run find enemies, which will gather up the number of enemies. That all happens on start. So, and then it'll do the update probably immediately on since the first frame. But that 1 second delay might be enough that it's populated the thing. So let's try that. And we may have to adjust that time to maybe 2 seconds or something longer. I wouldn't think so. Not a, oh wow, what happened? Well, it's saying enemies is 50, so we know it found the enemies, so that's a good thing. Maybe our speed is just like crazy high. So we're getting there. We're getting there. Let's go to plane. Let's set our speed down to 1 and just see what we've got here. Hit play. Let's see what happens. Okay, they're staying within the bounds, it looks like. But they're moving super, super fast. That's just too fast. So let's stop. That's probably way too fast. Let's try 0.1. 0.1. All right. Okay, so that's better. Speed is still too fast. We almost want to go half of that. We'll try half of that. 0.5. And let's see if we can increase our bounds here and see if it messes anything up. Go 7 and 7 on that. See what happens. I may have messed it up, but we'll see. We definitely got the speed down slower. No, I guess it's okay. They're still moving way too fast, though, aren't they? I'm looking at the scene view here just to see how close it's actually getting. Yeah, it still looks like we got a little. First off, we can slow down the speed, which this is going to be ridiculous. Let me just go down to 0.01, and we'll change this to 7.25, and that 7.25. Oops. Let's run that. Let's see what we have here. So now we're going the fifth of the speed that we were going before. It's probably about where we want to. So, see, they're colliding. So that was too far. You see how it messes it up because of the collision? They started piling up on each other. It's kind of wacky. All right, so let's. But I think the speed is going to be good because we can increase the speed as there's fewer and fewer enemies as they move down. I don't know exactly how the original Space Invaders does it. It's based on the number of enemies left or not. That's getting all messed up now. See, there's some physics now. They're trying to push each other. Some are going in the wrong direction. So we just need to leave this at 7.00 and 7. Just leave it at 7 and 7. Let's play that. Let that run for a little bit just to make sure we're getting them moving the right way. Yeah, moving as a group. That's what we want. We don't want them colliding into each other. So as soon as they hit that wall, if we allow them to hit the wall, the physics engine part kicks in because they both have rigid bodies. You know, they stop. It'll stop, and that'll throw things off. The other ones continue to move. They're trailing behind, so we just got to prevent that from happening before it happens. All right, so I guess what we also need to do is have the Y value change as well. Every time they change direction, we need to modify the Y value also. So let's see. That probably will be simple. The way we're going to, first of all, we can't, each enemy is going to have a different, well, each row is going to have a different Y value. All the enemies in a single row will have the same Y value, but I don't want to have to individually, figure out different Ys. The easiest thing I can think of right now, and this is a thing that's used sometimes, is what's called an offset. Because they're all going to offset or move from their current Y position down by the same amount. So we create an offset value, whatever that might be. Maybe it's, it's a floating point value, and maybe it'll be like 0.1. And so when the distance changes, the direction changes. Let's go to our script because it's easier to explain looking at the script. When we get down here, when we're changing direction, that's when we want them also to move down, or at least change the offset. So we can, let's create a variable up here. It'll be internal. It'll be a private. Private float Y offset. And semicolon. Okay, so Y offset. We're initially going to set it equal to 0. Because there's not going to be any change or offset. It's initially just going to be moving in its current position. everything's going to be moving. We're not going to change the y. But what we could do is when the direction changes, we'll reset the x low position, and we could say y offset minus equal, well, I guess we're gonna, if we're starting at offset of 0, in order to, when objects move down in 3D space on the y axis, the values decrease down to 0. So we need to be subtracting. So our offset always needs to be a negative value, but we're going to add it. Well, it doesn't have to be. It could be a positive value that we subtract or a negative value that we add. It's just, I guess we just keep it as a positive. We'll make it easy. So y offset plus equals 0.1. We're going to say f. And we're going to do that for both. Each time it changes direction, either going left or right, we'll add 0.1 f to to the y offset. Now, over here, we're going to have to use the y offset here when we're saying temp.x and all that, and change net speed plus direction. We probably want to make the y offset, that 0.1, a public variable so we can play around with some numbers. I think I'll do that. We'll change that. Well, actually it'd be a starting y offset. No, I take that back. Y offset is the value we're going to use here. Let's just plug this in first and get it working. We'll worry about that later. So now we need to alter. Oops. Really not altering, but right now, but because on the first pass, when y offset is 0, we're going to say temp y, which we're going to reset the y value. Y value equals y minus y offset. Well, initially it's 0, so it's not going to matter during this first pass. All the y is going to stay the same. But on the second pass, after it bounces off the left wall and starts going to the right, we want them to move down. We're increasing that offset value, which on the second iteration of the for each loop, where it's going through the game objects, or the second frame, let's say, well, not really the second frame, but the second time, it'll process for every frame. It's going to be processing the y offset, and the y offset will stay 0 initially until it reaches all the way to the left, but we'll update it every time the group of enemies bounces off a wall. We're going to keep increasing the offset so that the y positions will change. Let's see if that's correct. Let's see. It might not be. What I'm trying to do. Let's see. Let's try it. Sometimes I start making changes that may or may not work. But let's. Hold on. I got someone at the door. Be right back. All right, so I'm back. We are getting ready to. All right, sorry for that distraction. Okay, we got things back going. All right, let's hit this play. Let's just see what happens there. Again, I'm thinking it's. For some reason, I get this eerie feeling they're going to start coming down diagonally. When they start coming down, that it'll just mess it up. Maybe it'll do it right. Okay, we got some things to work out, as we can see. All right, so let's try to figure out what's going on here. For some reason, the y value is not being triggered. Let's look at our script again. Maybe it's just too small of a value that it's not in the y direction. It's not. We're not seeing it change. I guess I want to show that. I'm going to have to show. Since we know this works, let's just change this to y offset. And let's see what our y offset value is. Let's make sure, where is y offset being declared? It's up there, private float y offset. We initially set it to 0, that's fine. We're adding that, and then we're okay. And let's just set that to a value of 1 on the offset. So we want to see a little incremental drop there. Just want to make sure the offset is not being reset to 0 somehow anywhere, which it isn't. Okay. So let's do that. Let's run that. Let's see what happens. Well, it just disappeared. Oof. Yeah, that was extreme. So let's go back to our offset. Let's make that 0.1f. 0.1f. Something happened. We just don't know what. That must have been a pretty big jump. And it was gone in no time. They were off the screen. They went straight south. South for the winner. Oh, wow. I think what happened is that value of y wound up being more than the gap between those, and so they collided, I think, into each other, maybe. Ah, jeez. Yeah, we're definitely have to set that up as a public so we can play around some numbers without jumping back and forth into this script. So let's do that. Let's call it public float the incremental y, maybe inc y, the increase of y, like what value you want to increase by, and we will change the hard-coded values here to inc y. So let's save that. Give Unity a second to update. As soon as we see inc y here, we can set it. We know that 0.1 was too high. Let's do half of that. I don't really know what the distance is. I guess I could look at, the smartest thing would be to look at the script that spawns in the enemies. So it looks like we multiplied by x and y was by 1.1, whatever rho is, times 1.1. Let's see if we can figure out. See, actually, I would think that that would have worked, though. But anyways, let's. So let's go into Unity. We have on the plane. Okay, so we now have that. Let's hit play and let's see what happens with 0.05. Yeah, that didn't work either. So obviously something is just really wacky with this stuff. The wonder of physics. So I don't think we need. We don't really need that physics activity to be going on because we just want to control the enemy. Not really. It's not like a collision where they're going to be deflected off somewhere. Let's remove the. Well, let's save our game scene first of all. And let's look at our enemy prefab. And there's really nothing special about all this. So we might be able to just remove the box collider. I mean the rigid body component. Because we're not doing any physics with it. You know, we're just manually controlling it. So let's remove that component altogether. Now let's run. Let's just see what happens. Let's just see what happens with that removed. Okay, see it incrementally, and that's what I suspected. It kept, on each iteration, it kept adding y to the offset, adding again and again and again and again. So what's going to have to happen is the first time that when it jumps down, we move it down a row. After it goes through the first iteration where it's moved all the cubes down one row, then the offset needs to be set back to 0 until it hits the right side of the wall. So it only needs to happen one time. So let's look at our script. We are going to have to make a change to the script then. So here's the Y offset. So that's done after this for each. So basically what it means is on the next iteration, it's going to use that Y offset and adjust everything. And so I think what we can do is right here, after it's used, we can just reset it to 0 here. Equals 0. Reset offset. So if it's been set here, the next time it comes through the update, it'll use that offset and then reset it to 0 immediately after it finishes. Actually, we want to finish the whole thing before then we reset it, and then we want to make sure the for each finishes before. We don't want to reset it in the middle of this for each loop. We want to let it readjust all the blocks by the offset, and then it sets it to 0. And then it does a check for the direction, and if we've reached, an extreme left or extreme right, it will calculate that, reset the offset. But at least, and then the Y offset then will be ready to be whatever value is set down here in the direction if statements. It'll be used on the first iteration of update again in the next frame, and in the for each loop one time, and then it'll get reset back to 0. I think that'll correct our issue. That was probably the issue. We could have probably left the rigid body, but I just realized what the issue was. Anyways, so let's save that. Let's go back here, hit play. And I'm going to leave the rigid body out. We don't need it. Like I said, we don't need it. We're not doing any kind of physics simulations. Yeah, so that's what I wanted. I want it to be used once to move them down to a different Y, and then that Y is remembered, so they'll keep moving on that same Y. So it seems to be working. And I think our speed is actually okay. So we could always readjust that. The offset value. So yeah, that seems to be working. And actually, this is good because since we didn't since we don't have the physics, the rigid body, when it got down to the defense shields, we'd have an issue with that anyways. In the actual game, what happens is when they shoot their missiles, it can actually destroy a partial part of the defenses, or if it has a complete row like it does, it's getting down and starts wiping off the top, it would actually etch away or remove part of the defense shield starting from the top, working its way down. So I know the way this is set up right now, it's a solid cube. So the only way that I was thinking about, because I was thinking about this before, to be able to have destruction occur to the defense shields would be to redo a prefab of the defense shields made up of multiple I guess like multiple cubes, mini cubes. Think of a 3 by 3 by 3 like in three-dimensional space. So maybe keep it simple like that. So it'd be consisting of 9 sections basically. 3 rows, 3 columns, so 3 by 3. And so if it hit like the top left, that top left, think of a tic-tac-toe, just that look. And so the the top left would come apart, or the top right with the missiles. But now when it's rubbing across like this, the enemies could wipe out the top 3 off that layer. So I'm gonna let that run. I'm put you. I gotta deal with something right now. Be right back. Okay, so yeah, as you can see, they're slowly working through our defenses, and we'll have to deal with that at a later time. And like I said, making a 3x3, redoing the prefab for that is probably going to be in order. Initially, I'll probably just leave them just the way they are, and it would act as they just won't deteriorate, and we'll just get it to the point where our player can launch missiles. The enemies can launch missiles, and we can do some destruction there. I could just change the shield to have like a hit point counter. Maybe each one starts at 10, so each time a missile would hit one of them, the counter would go down, and I could display that hit point on the front surface of each one, so you know at any given time what your defenses are at on that, and we won't have to get anything complicated, because I kind of want to just finish this, and we've learned a lot in this, and I think we can move on to doing something a little bit better. I kind of want to do like a side scroller type, and this was originally going to be 2D game development, and really we're not doing any 2D here. We're using a 3D environment for this, and Unity has a complete 2D toolkit, and I'd like to play around with that and really get into that and do a truly 2D side-scrolling parallax type game to get familiar with their 2D game kit they have. Yeah, so anyways, we're making progress. So as you can see, our enemies are moving down, working away. I think we just need to figure out how we're going to increase the speed as it goes. Is it going to be as they get further down it goes faster, or is it as enemies are eliminated then it starts moving faster? Based on, we could do some checks. Like for every 5, since there's 50 of them, for every 5 that disappear, they start moving a little bit faster each time, or maybe each one will break. We got 50 enemies. We'll look at what our max speed could be that doesn't, cause any problems with collisions on the walls, and we'll divide 50 into what our maximum increase of speed would be to get an incremental amount, and then every time an enemy is destroyed, it will increment the speed by that incremental amount, and that way it can be progressive, that way. And there's several ways it can be done. So when you're making a game, it's your time. You can make your own rules, excuse me, and develop it any way you want. So, but you see, we're definitely showing some progress here. So I guess our next video will be on creating a missile that our player can launch, and so we've got to get that going, and you can only fire one at a time. So while if you miss and it's just flying up in the air until it disappears. We have to have it disappear after a certain height, which would be actually just above the starting point of these enemies. We also need to work in a what do you call it? A bonus UFO ship that hovers above the top of the enemies. That's going to be further up there. We need to work that in. I might need to adjust the cameras a little bit to show that. This angle may not exactly show it, so we may have to adjust that. I'm also thinking about potentially doing something with the camera view so we can zoom in and get a closer view, which would make it easier to play, and have, as the player moves left to right, so we can actually get a better view, the camera would follow, you know, the player. So you might not necessarily see all the enemies at one time, but you're just seeing the area where you're at, and this way we get maybe a pretty cool angle on that and camera movement. You'll see what I'm talking about later on. We'll worry about that later. We just want to get this thing completed, get some destruction going on. That's our next thing with the missiles from both the enemy and the player, starting with the player. And obviously when they reach this level and they hit you, normally we have to hit you once with a bomb, or an enemy hits you, you die. So we'll have to work in a 3 live system and a respawn kind of. We'll have to figure that out. And I think for this first variation, rather than do lives, it'll be, we could implement the same thing with hits. So take so many hits, so it's the equivalent of lives. I mean, it's, and we don't have to worry about the respawn right now. I did see a tutorial that was, or a reference in the documentation about how to do a respawn, and that may be what we need to do, something like that. But like I said, I want to move on to another project. We've learned a lot from this, but we'll get the basic functionality working. We'll make a few modifications that simulate what we need to. Initially, it'll be, I think, we'll have a hit point value of 10 for the defenses and 3 for the player. So when you hit 3 times, that's when the game's over. You get like 3 lives that way. It'll just take 3 hits. And that'll show on the player pad. Will start as, you know, whatever number of lives you start with. It could be 5. Maybe we'll do 5. Just depends on how difficult the game seems to be. All right, so we'll call it at that. That's going to be it for a little while here. I may get on later and do another video. I hadn't decided yet. Probably going to watch some other videos, research a few things, eat some dinner, that kind of thing, take a little break, and we'll launch this up again later if I'm feeling up to it. If not, I'll definitely be on tomorrow evening. We'll pick up in the next video. So until then, take care. Hopefully see you then.